our very first lesson, we will talk about science. What is science? The word science comes from the Latin word scientia, which means knowledge. As for today, science can be defined as a process, a system of knowledge, and a field of study to get a better understanding of the world we live in. The main purpose of doing science is to explain everyday phenomena and derive models of reality. Science can be divided into two broad divisions: the physical sciences and the biological sciences. The physical sciences deal with the study of non-living things and can be divided into the following specific fields: chemistry, where we learn about matter; physics, where we deal with the interaction of matter and energy; and earth science, where we study about Earth. Earth science is further divided into astronomy, the study of celestial bodies; geology, the study of the Earth's crust and its changes; hydrology, the study of fresh water like rivers and streams; meteorology, the study of Earth's atmosphere; and oceanography, the study of oceanic phenomena. The biological sciences are involved with the study of living things and can be divided into two main branches: botany, the study of plants, and zoology, the study of animals. These two branches are further subcategorized into anatomy, the study of internal structures and form of organisms; cytology, the study of cells; physiology, the study of functions and activities of cells, organs, and tissues; embryology, the study of development of organism from a fertilized egg; genetics, the study of heredity; taxonomy, the study of grouping and naming of living things; and morphology, the study of external forms and structures of organisms. Other sciences include the interconnection between these two broad divisions. For example, biochemistry, the study of substances in living organisms and their reactions; microbiology, the study of microscopic organisms; and ecology, the study of the relationships between living organisms and their environment. In doing science, a scientist must possess scientific attributes which include patience, open-mindedness, honesty, curiosity, hard work, critical thinking, and a long-lasting interest to search for truth. To solve problems at hand, scientists use a systematic way called the scientific method. It includes the following steps: identification of the problem based on relevant observations; formulation of an intelligent guess referred to as hypothesis; collection of data through experimentation; analysis of data; and drawing conclusions. This scientific method can also be applied in daily lives. For example, a mechanic has to repair a broken car. First, he makes observations by trying to start up the car, examining the gauge, and listening to the engine sound. He then makes a hypothesis about what causes the problems. Faulty parts of the car are then repaired and replaced. Then the mechanic tests the car again to see if it can run properly. Finally, the condition of the car is established. Most of the problems can be solved successfully using the scientific method, and it plays a great role in scientific progress. Science and technology are often mentioned together. What is their relationship? Basically, technology is the practical application of the science with the purpose of providing benefits to humankind. You can find examples of technology everywhere, such as cars, elevators, cameras, soap, medicine, clothing, processing foods, and of course, the device you are using to watch this video. Despite making our lives easier in many ways, science and technology can have their negative impacts also, and they can be quite dangerous. Examples include environmental pollution, new diseases, global warming, and climate change. Therefore, as a student of science, you should be able to decide wisely which part of science and technology can be advantageous or disadvantageous to human lives. That ends our lesson for today. I hope you enjoyed learning with us. For more videos like this, subscribe to our YouTube channel and hit that notification button. I'll see you in the next lesson. Hi class! For this lesson, we will talk about basic science process skills and how they are utilized in conducting scientific investigations. The key to doing science is understanding what scientists do. This primarily involves acquisition of knowledge, and there are several ways of acquiring knowledge. This can be through any of the following: habits, intuition or guesswork, authorities, reasoning, experiences, and science. Among those mentioned, acquiring knowledge through science is the most logical and systematic way. In order for us to acquire knowledge through science, we need some basic skills, and this include the following: observing, communicating, measuring, classifying, inferring, and predicting. Observing is a skill where we use our senses: sight, hearing, touch, taste, and smell. Observations can either be classified as qualitative or quantitative, both of which use our senses. In quantitative observations, we utilize instruments or tools such as rulers, balances, or thermometers to provide an observation that is measurable or quantifiable. After observation, we can now relay or communicate in order to share gathered information. This skill is called communicating. Measuring is another skill which involves ascertaining a property of a material and expressing it in a defined unit. As an example, the length of a wooden stick can be expressed in a standard unit called meter, while the mass of the same wooden stick can be expressed in grams. A measurement typically contains two parts. One, a number or magnitude, which tells how much or how many, and two, a unit or dimension, which tells how much of what. Classifying is a skill which involves grouping of sets of information, objects, or events based on similarities, differences, and interrelationships. This skill is important because it is assumed that if a set of objects shares something in common, it may also share other attributes as well. Next skill is inferring, which can be derived from an outcome of an observed event. Inferences are explanations or interpretations that usually follow after an observation. Inferences are influenced by our own personal experiences and may change as we make more observations. Hence, our inferences may continually be modified and at times can be accepted or rejected. Lastly, predicting is a skill defined as projecting about the outcome of an event. Good observations and good inferences may lead to sound predictions. Because predictions are based on observations and inferences, it is important to note that predictions are not simple guesses and are thus testable. As students, integrating these basic science process skills will make our learning experience richer and more meaningful. These basic process skills will also become helpful when presented with problems and carrying out scientific investigations. That ends our lesson for today. I hope you enjoyed learning with us. For more videos like this, subscribe to our YouTube channel and hit that notification button. I'll see you in the next lesson. Measuring is another skill which involves ascertaining a property of a material and expressing it in a defined unit. As mentioned earlier, measurements are expressed in standard units. In 1960, the International System of Units, abbreviated as SI, has been adopted and is continuously being used with the purpose of providing a coherent and standardized unit system. In our daily lives, we use SI unit to describe common physical quantities: length in meters, mass in kilograms, time in seconds, electric current in amperes, temperature in Kelvin, and volume in cubic meters. For extremely large and extremely small numerical values, decimal multipliers are very helpful in describing such quantities. Decimal multipliers are simply fractions or multiples of the base unit. The mass of an object can be expressed in grams, kilograms, or milligrams, where a kilogram is equivalent to 1,000 grams, while 1 milligram is equivalent to 1 over 1,000 gram. For example, the mass of a sack of rice is usually expressed in kilograms, while the mass of a microchip in a computer is more suitable to be expressed in milligrams. Consider the number of atoms in 1 mole of an element, or the radius of a hydrogen atom. For extremely large and extremely small quantities, there is a more convenient way to express such values. This is called the scientific notation. A scientific notation is expressed in this format: n times 10 raised to a, where n is the numerical coefficient between 1 and 10, and a is the power of 10, which indicates the number of times the coefficient is to be multiplied or divided by 10. Here is an example. In doing measurements in science, we often need to convert one unit of measurement to another unit. We can do this by using a method called factor label method, commonly known as dimensional analysis. This approach allows us to convert an initial unit of measurement to our desired unit of measurement using a valid conversion factor. A conversion factor is equal to 1. Therefore, multiplying or dividing a given quantity with a conversion factor will simply transform the initial value to a new value expressed in a different unit of measurement. Here is an example. That ends our lesson for today. I hope you enjoyed learning with us. For more videos like this, subscribe to our YouTube channel and hit that notification button. I'll see you in the next lesson. In our previous lesson, we learned about the steps in scientific method. 1. Identifying the problem. 2. Formulating the hypothesis. 3. Gathering data by experimentation. 4. Interpreting the data. And 5. Making conclusions. Identifying a problem involves specific variables that can be manipulated, observed, and controlled. A good problem should have the following characteristics. It should have a significance in one or more academic fields of study. It should be clear and concise. It has a basis in research literature, and it should be doable within a set time frame and budget. After a research problem has been identified, a hypothesis can be formulated. The hypothesis can serve as a guide for the researchers as to what facts are relevant toward answering the problem. The next step is called experimentation, which involves identifying the exact problem to be solved, identifying variables to be controlled, and designing the step-by-step procedure to be carried out in the experiment. Data in the form of qualitative and/or quantitative observations are gathered during experimentation. It is where various science process skills such as measuring, classifying, comparing, and estimating can be applied. Interpreting the data means that the raw data needs to be organized and processed to generate a more compact and meaningful information to solve the problem. Finally, generalizations based on findings are drawn. A conclusion is simply a direct response to the problem under investigation, and it should confirm or disprove the hypothesis initially posted for the problem. Most of the problems can be solved successfully using the scientific method, and it plays a great role in scientific progress. That ends our lesson for today. I hope you enjoyed learning with us. For more videos like this, subscribe to our YouTube channel and hit that notification button. I'll see you in the next lesson. For this lesson, we will focus on the basic aspects of matter. What is matter? Matter is anything that has mass and occupies space. It is everything the entire universe is made of. Matter exists in 4 states: solid, liquid, gas, and plasma. Solid has definite shape and volume due to the closely packed and orderly arrangement of particles. Tables, chairs, and blackboards are some examples. A liquid occupies a definite volume, but the form of the container is assumed. Examples include water and juice. A gas has no definite volume or form and expands quickly to fill its container fully. Examples include carbon dioxide and oxygen. Plasma is highly ionized gas that exists at very high temperatures. Examples are flame, stars, and the sun. Matter can be described and identified by its physical or chemical properties. Physical properties are those that can be observed and measured without altering the composition of matter. Examples are smell, color, scale, shape, boiling point, density, solubility, and viscosity. Chemical properties are properties that can be observed when matter undergoes a chemical change. Examples include flammability, acidity, stability, and other properties related to the reactivity of one material or another. Physical properties of matter can also be categorized as intensive or extensive. Intensive properties are independent of the material quantity. These properties are intrinsic in the substance and remain the same regardless of whether the quantity of the material is small or large. Examples are color, temperature, melting point, and boiling point. Extensive properties depend on the quantity of the material. These properties assume higher values when the substance is larger and lower when the substance is smaller. Examples include mass, length, and volume. All chemical properties are intensive properties. That ends our lesson for today. I hope you enjoyed learning with us. For more videos like this, subscribe to our YouTube channel and hit that notification button. I'll see you in the next lesson. Different types of matter with specified properties can be divided into two main categories: pure substances and mixtures. Pure substances are of constant composition. They have similar structures and the same physical and chemical properties. Pure substances cannot be divided by physical means into two or more substances. Water is an example. On the other hand, mixtures consist of two or more component substances that are physically combined without definite proportion and can be distinguished by ordinary physical means. Salt water is an example. Mixtures can be heterogeneous or homogeneous. A homogeneous mixture, even though it consists of many components, has only one phase. The entire mixture has a uniform composition, and the components cannot be separated from each other. Examples of this are solutions. Heterogeneous mixtures consist of two or more different phases that can be easily identified because they are formed separately. Its composition is not uniform throughout the mixture. An example is a mixture of oil and water. Heterogeneous mixtures can be further categorized into suspension, colloid, and coarse mixtures. A suspension is a mixture of liquids with particles of an undissolved solid. Salad dressing is an example of a suspension. A colloid is an intermediate between a solution and a suspension. Particles of a colloid do not separate and can be distinguished using scattering of light called Tyndall effect. When light passes through a colloidal solution, light scatters because of the particles dispersed in the solution. Lastly, coarse mixtures are those which are simply combination of two or more substances, whose particles are larger than those of suspensions and colloids, and which are easily identified by naked eyes. It is possible to further identify a pure substance as either an element or a compound. An element is considered to be the simplest type of matter, since it contains only one kind of atom. It cannot be broken down into simpler substances through physical or ordinary chemical means. Examples of elements include carbon, oxygen, and hydrogen. Each element has its own unique chemical name with its corresponding chemical symbol. An element symbol consists of 1 to 3 letters, with the first letter in uppercase and the remaining letters in lowercase. They are organized in a table called the periodic table of elements to provide a systematic and logical arrangement of the recognized chemical components. The elements are arranged into a grid of horizontal rows called periods and vertical columns called groups. Elements belonging to the same group have comparable physical and chemical properties. Elements are also classified as metals, nonmetals, and metalloids. Metals are located at the left side of the periodic table. Iron, copper, gold, and zinc are examples. These elements are ductile. malleable, lustrous, good conductors of heat and can be formed into alloys. Non-metals like oxygen and chlorine are found at the right side of the periodic table. They are non-lustrous and poor conductors of heat and electricity. Semi-metals or metalloids are those elements between metals and non-metals. Examples of these elements are boron, silicon, germanium, and tellurium. Some of these elements are used as semiconductors in the electronic industry. A compound, on the other hand, is another class of pure substance. A compound consists of two or more distinct elements that are combined chemically by mass in a given proportion. Each compound has physical and chemical properties that form properties of its component elements in a specific way. Water, composed of hydrogen and oxygen, is an example. From their constituents, the chemical formulas for compounds are extracted. For example, water has a hydrogen and oxygen ratio of 2:1. Therefore, the formula is H2O. Compounds can be broken down or decomposed into its constituent elements by chemical means requiring external energy such as heat, light, or electricity. That ends our lesson for today. I hope you enjoyed learning with us. For more videos like this, subscribe to our YouTube channel and hit that notification button. I'll see you in the next lesson. When matter undergoes change, it can be physical, chemical, or a nuclear change. A physical change occurs when matter undergoes a change in appearance, like shape, size, or phase, but not in chemical composition. They include changes such as ripping, crushing, folding, and shattering, and are relatively easy to reverse. Other examples of physical change include melting, freezing, evaporation, condensation, sublimation, and deposition. These processes are also called phase changes because of matter's transition from one phase to another. Chemical changes, also called chemical reactions, occur when a process results in a new substance being formed with new properties. These are often accompanied by changes in color and/or temperature. They are also more difficult to imagine being reversed. Examples of chemical changes include cooking, digestion, roasting, burning, and photosynthesis. Finally, a nuclear change occurs when a subunit of a particle of a matter, the nucleus, breaks apart to form smaller atoms called nuclear fission, or fuse together to make heavier atoms called nuclear fusion. This involves about 1 million times as much energy as a chemical change. As mentioned, nuclear reactions involve a change in an atom's nucleus, usually producing a different element. Chemical reactions, on the other hand, involve only a rearrangement of electrons and do not involve changes in the nuclei. Examples are the reactions with alpha and beta radiation. Atomic bombs are nuclear weapons that use the energetic output of nuclear fission to produce massive explosions. That ends our lesson for today. I hope you enjoyed learning with us. For more videos like this, subscribe to our YouTube channel and hit that notification button. I'll see you in the next lesson. For this lesson, we will talk about solutions in homogeneous mixtures. Solutions can be found everywhere. Pure air, nutrients in our body, and soil minerals absorbed by plants are examples of solutions around us. It is important to learn about solutions so we can utilize them better in daily lives. What is a solution? A solution is a homogeneous mixture of particles of two or more substances. A solution consists of two components: solute, which is the dissolved substance, and solvent, the dissolving medium. For example, sugar solution is the solution consists of sugar as the solute and water as the solvent. As discussed previously, pure substances can be elements or compounds. Elements' smallest particles are atoms. Covalent compounds' smallest particles are molecules, while those of ionic compounds are ions. To form a solution, the ions, atoms, and molecules of solute must be surrounded by solvent molecules. This is called solvation process. A solution can be in any state of matter: solid, liquid, or gas. A solid solution has its solid component dispersed throughout the atomic or molecular arrangement of the solid solvent. For example, steel is a solution of carbon in iron. A liquid solution is made by dissolving any solid, liquid, or gas in a liquid. When water acts as a solvent, the solution is called aqueous solution. For example, a soft drink is a solution of carbon dioxide in water. A gaseous solution is made by mixing one gas with another. For example, the air around us is a mixture of nitrogen, oxygen, carbon dioxide, and other gases. Compounds inside a solution can be electrolyte or non-electrolyte. An electrolyte is a compound that acts as a conductor of electric current. Otherwise, it is non-electrolyte. You can do the test using this conductivity apparatus. Try to dip the metal strips into the solution. If the light bulb glows, it means the compound is a conductor of electric current or an electrolyte. Generally, aqueous solutions of ionic compounds such as sodium chloride and sodium hydroxide are electrolytes, whereas those of covalent compounds like sugar or alcohol are non-electrolytes. That ends our lesson for today. I hope you enjoyed learning with us. For more videos like this, subscribe to our YouTube channel and hit that notification button. I'll see you in the next lesson. A certain solution can be considered as saturated, unsaturated, or supersaturated solution. When you add a few crystals of sugar in water, these crystals are easily dissolved. Adding more crystals will result in some of them settling at the bottom of the glass. These are usually dissolved by stirring or shaking the container. As you add more sugar, you will eventually come up with a solution with undissolved crystals. A saturated solution is a solution that contains the maximum amount of dissolved solute for a given amount of solvent at a specific temperature and pressure. In our example, the solution was said to be saturated when the amount of sugar that can be dissolved reached maximum. The maximum amount of solute that can be dissolved at a given temperature to make a saturated solution is called the solubility of that solute. It is usually expressed in grams solute per 100 milliliters or per 100 grams of solvent. If the amount of solute in a solution is less than the saturation amount, the solution is said to be unsaturated. If the amount of solute exceeds the saturation amount, it is called supersaturated. Concentration of solution can be expressed using percent by mass and percent by volume. Percent by mass is the mass of solute divided by the total mass of solution multiplied by 100%. A 5% by mass of salt solution contains 5 parts of salt for every 95 parts of water. Therefore, in 100 grams of that solution, there are 5 grams of salt and 95 grams of water. Likewise, percent by volume is the volume of the solute divided by the volume of solution multiplied by 100%. It is frequently used to express the concentration of a solution of two liquids. For example, a wine that is 20% alcohol has 20 milliliters of alcohol per 100 milliliters of wine. If you know the concentration of a given solution, you can prepare a less concentrated solution by adding some amount of solvent. This is called dilution. During the process, the solute to solvent ratio decreases. That ends our lesson for today. I hope you enjoyed learning with us. For more videos like this, subscribe to our YouTube channel and hit that notification button. I'll see you in the next lesson. There are 3 factors that affect solubility: the nature of solute and solvent, temperature, and pressure. The general rule in solubility is like dissolves like. Polar and ionic solutes are soluble in polar solvents, while nonpolar solutes are soluble in nonpolar solvents. Water is a polar substance. That is why polar substances like sugar and ionic substances like salt are soluble in water. Nonpolar substances like vegetable oil are not soluble in water, but they are soluble in nonpolar substances like benzene. Temperature affects solubility of 2 types of solutions: solids dissolved in liquids and gases dissolved in liquid. The solubility of solid salt in liquid increases with temperature. If you dissolve the same amount of salt in warm and cold water, you will see that the salt in warm water dissolves better than in cold water. For the solubility of gases in liquid, we can look at the solubility of oxygen in water. Do you know why fishermen do their fishing very early in the morning or late in the afternoon? It is because at very high and very low temperatures, there are less oxygen dissolved in water. It makes the fish less active. Unlike solids, most gases become less soluble in liquid as the temperature increases. When we heat water, bubbles of air are formed before water boils. It is because when temperature increases, the dissolved air boils out first before the water itself boils. In a solution of gas in a liquid, the amount of gas dissolved is directly proportional to the pressure exerted by the gas over the solution. This is called Henry's law. That explains what happens when you open a bottle of soft drink. carbon dioxide gas is incorporated in the drink through high pressure. When you open the bottle, the pressure inside the bottle decreases, so the solubility of carbon dioxide also decreases, making the soft drink bubble or fizz. That ends our lesson for today. I hope you enjoyed learning with us. For more videos like this, subscribe to our YouTube channel and hit that notification button. I'll see you in the next lesson. For this lesson, we will talk about the science of acids and bases. You probably have encountered some acids and bases. For example, vitamin C is ascorbic acid, while vinegar contains acetic acid. Sodium hydroxide, the most commonly known base, is used to make soap, while ammonia is used as disinfectant. You've also probably heard about acid rain, which can kill fish in damaged buildings. There are some theories about acids and bases. In 1894, Svante August Arrhenius proposed that acids and bases may be defined in terms of the ions they form when dissolved in water. According to him, an acid is a substance that yields hydrogen ions, and a base is a substance that yields hydroxide ions. Therefore, hydrochloric acid is an acid because it yields hydrogen ions, and sodium hydroxide is a base because it yields hydroxide ions in water. Johannes Nicholas Bronsted and Thomas Lowry suggested a more general definition of acids and bases in 1923. According to their theory, an acid is any substance that can donate a proton to another substance, and a base is any substance that can accept a proton from another substance. The acid's strength depends on its tendency to donate protons, while the base's strength depends on its tendency to accept protons. In 1923, Gilbert Newton Lewis developed an even more general theory based on the sharing of electron pair between acids and bases. From his point of view, acid-base reaction can occur if there is a molecule or ion that can accept electron pairs, and a molecule or ion that can donate electron pairs. That ends our lesson for today. I hope you enjoyed learning with us. For more videos like this, subscribe to our YouTube channel and hit that notification button. I'll see you in the next lesson. Acids and bases have very distinct properties that enable us to distinguish one from another. Acids have sour taste, while bases taste bitter. Vinegar tastes sour because it contains around 5% acetic acid, and ampalaya or bitter melon extract is bitter because it is basic. Bases are also slippery and soapy. Both acids and bases can cause color changes in plant dyes. Acids change litmus paper color from blue to red, while bases change it from red to blue. This is why litmus can be used to identify acids and bases. Acids react to certain metals like calcium and iron to produce hydrogen gas. Both acids and bases are electrolytes. Here are some examples of acids and bases in our daily lives. Sulfuric acid is used in some industrial processes, such as in manufacturing fertilizers, dyes, and drugs. It is also used in lead storage battery. Hydrochloric acid is used in metals and foods industries. The gastric juice in the stomach is hydrochloric acid, which can aid food digestion. Nitric acid is used to produce fertilizers and explosives such as dynamite. Acetic acid is a component of vinegar. It is also found in body fluids and plant juices. Sodium hydroxide is used for making soap, paper, rayon, and other chemicals. Magnesium hydroxide has long been used to relieve hyperacidity and constipation. Ammonium hydroxide is commonly used as household cleaner. To measure the acidity of a solution, we use the pH scale. pH is an abbreviation for the power of hydrogen. The pH values range from 0 to 14. Acidic solution has a pH value less than 7, while basic solution has a pH value greater than 7. Solutions having a pH of 7 are said to be neutral solutions. Another general properties of acids and bases is they can neutralize each other. The reaction is called neutralization. It occurs when an acid reacts with an equivalent amount of base and forms a neutral solution containing salt and water. An example of neutralization is how we treat hyperacidity. The gastric juice in our stomach has a pH of about 1.5. When someone has hyperacidity, the excessive high acidity can cause inflammation and discomfort in stomach membrane. Antacids are usually prescribed to reduce the concentration of hydrogen ion in the stomach. Antacids contain active ingredients such as magnesium hydroxide that acts as a base to neutralize the excess of hydrochloric acid in the gastric juice. That ends our lesson for today. I hope you enjoyed learning with us. For more videos like this, subscribe to our YouTube channel and hit that notification button. I'll see you in the next lesson. To measure the acidity of a solution, we use the pH scale. pH is an abbreviation for the power of hydrogen. pOH is a measure of the basicity of the solution. pH and pOH are related according to this equation. The pH values range from 0 to 14. Acidic solution has a pH value less than 7, while basic solution has a pH value greater than 7. Solutions having a pH of 7 are said to be neutral solutions. pH is very important in our body. Our blood has a pH of about 7.4. If the pH changes, a serious illness can occur. Acidosis occurs when blood pH becomes lower than 7.4, while alkalosis is when the blood pH exceeds 7.4. In agriculture, the pH of soil indicates what kind of crop is suitable to grow in it. Rice, coffee, and banana grow in acidic soil, while grapes and cabbages need basic soil. pH also plays important roles in toiletry manufacturing. Shampoos are usually pH adjusted based on different types of hair. Shampoos for kids have a pH of about 7.4, same as the pH of tears. This is to prevent eye irritation and therefore prevent tears. The pH of a solution can be roughly determined using an indicator that can change the color of the solution within a particular acidity. Many indicators are pigments extracted from plants such as black beans, roses, and red cabbages. The pH values can also be measured using a pH meter. It consists of a probe that is made up of glass electrode and a reference electrode. The electrodes are hollow bulbs containing potassium chloride solution with a silver wire suspended in it. When the probes are placed into a solution, the hydrogen ions in the solution will move toward the glass electrode and replace some metal ions on the glass coating. This will generate a tiny voltage across the bulb. The voltage will then be sensed by the wire, passed on to the voltmeter, and be converted into an equivalent pH value. That ends our lesson for today. I hope you enjoyed learning with us. For more videos like this, subscribe to our YouTube channel and hit that notification button. I'll see you in the next lesson.